Welcome to another episode from this channel. Today we're going to look at a paper by Colleen B. Young, and the title of this paper is The Static Allometry of a Small-Bodied Omnivore, Body Size and Limb Scaling of an Island Fox and Inferences for Homo floresiensis. Before we get into the meat of the video, don't forget to like, comment and subscribe, and also the link for this particular paper will be down below in the description box. So without further ado, let's have a read through the highlights and the abstract. So with the highlights, we've got dwarfism in the island fox corresponds with novel community resource dynamics. The small-bodied island fox is not a scaled-down version of the mainland fox. Body size reduction in an island omnivore produces unique body proportions, and body size and proportions of Homo floresiensis are likely ecological adaptations. So basically this kind of hinges on the whole dichotomy between island creatures, mammals in particular, and mainland creatures, mammals as well. So for example, in many island regions throughout the world, there's dwarf elephants, there's dwarfed mammoths, and on some islands then you've got enlarged creatures like lizards. For example, the Komodo dragon is just an enlarged lizard really. You had the giant stork many thousands of years ago on the island of Flores, etc, etc. But here we're looking at the allometry, measurement-based analysis of the island fox. So the first thing to note is dwarfism in the island fox corresponds with novel community resource dynamics. So as with anything, there's always something that influences the lifestyle or behavior of a creature. So for example, in the case of an island fox, their prey may change from prey item to prey item depending upon availability, how easy it's to get access to those creatures, and if necessary adapt to an alternative food source. So dwarfism in the island fox corresponds with novel community resource dynamics. So changes in the resource dynamics in the ecosystem causes this dwarfism in the island fox. The small-bodied island fox is not a scaled down version of the mainland fox. The body size reduction in an island omnivore produces unique body proportions. That'll be explained further in the paper. And then body size and proportions of Homo floresiensis are likely to be ecological adaptations. So let's have a look at the abstract to kind of put more meat on this. Island dwarfing is a paraphyletic adaptation across numerous mammalian genera. From mammoths to foxes, extreme body size reduction is shared by diverse organisms that migrate to an island environment. Because it largely occurs owing to ecological variables, not phylogenetic ones, the skeletal characters in a dwarfed taxon compared with its ancestor may appear abnormal. As a result, allometric pattern between body size and morphological traits may differ from an island dwarf compared with its ancestor. The diminutive late Pleistocene hominin Homo floresiensis displays a unique character suite that is outside of its normal range of variation for any extinct or extant hominin species. I think what is being said there at the moment is that in the case of Homo floresiensis, some have suggested it is a dwarfed version of Homo erectus. Here it's suggested it's not. The Homo erectus may have been the antecedent, may have been the original parent species, but comparing the skeletal morphology of Homo floresiensis to Homo erectus, you will notice differences between the two hominins. There's broad brushstrokes that shows that they're related in some way, but if you look at all of the suite of characters, and when I say characters, I mean features on the bones, like, you know, an enlarged muscle attachment maybe on the arm or something along those lines. There's a whole suite of those kind of characters all across the skeleton of Homo floresiensis that you won't find in Homo erectus, and that's what's kind of being said here. Simply just saying that Homo floresiensis is a dwarfed version of erectus misses the nuance. Okay. The diminutive late Pleistocene hominin Homo floresiensis displays a unique character suite that is outside of the normal range of variation for any extinct or extant hominin species. To better explain these as ecological traits due to island dwarfing, this research looks at how dwarfing on islands influences limb scaling and the proportions on an organism in a similar ecological niche as Homo floresiensis. Here, this is Colleen Young. Here, let's see, I analyse absolute limb lengths and static allometry of limb lengths regressed on predicted body mass of dwarfed island foxes and their non-dwarfed relatives. Dwarf island foxes have significantly smaller intercepts but steeper slopes of all limb elements regressed on predicted body mass than the mainland grey fox. These allometric alterations produce limbs in the island fox that are significantly shorter than predicted for a non-dwarfed grey fox of similar body mass. In addition, the humerofemoral, intermembral and brachial indices are significantly different. These results provide a novel model for understanding skeletal variation of island endemic forms. Unique body size and proportions of Homo floresiensis are plausible as ecological adaptations and likely not examples of simplesiomorphies with Australopithecus species. Caution should be exerted when comparing an island dwarf with a closely related species, as deviations from allometric expectations may be common. So that's basically it's very detailed kind of explanation of the results of the allometric analysis. What we're seeing here is that when you look at the predicted downscaling of the size of a grey fox, for example, the numbers come out differently to what we see in the species on the island fox. So the dwarfed island foxes have significantly smaller intercepts but steeper slopes of all limb elements regressed on predicted body mass than the mainland grey fox. So it's I'll need to read a good bit more into this paper, but it kind of I think we kind of knew this, but when I say we kind of knew this, it makes sense, but it hadn't been really tested just to prove there was something going on here, you know. And that makes sense. Imagine now you're a Homo erectus and you land on Flores, however many hundreds of thousands of years ago, maybe even millions of years ago, and then over the next few 100,000 years, then various ecological pressures means that you end up shrinking in size. There's not very many predators that could do away with you, and so size isn't necessary, and so your whole kind of body shrinks, but you keep your cognitive abilities relatively intact. The brain is just rewired and shrunk. And certainly there's some suggestion that Homo floresiensis used stone tools, which is well within the lines of a hominin that had a cognitive capacity unlike those of Australopithecus, maybe the early representatives of Australopithecus. It'll be interesting to see if any stone tools would be found with, let's say, Australopithecus sedina. I do know that the group of hominins dated to around 1.9 million years of age, so certainly that Australopithecine could have made stone tools, and certainly the opposable thumb on that creature is a giveaway that they were able to use a good human-like grip. So let me know what you think about that paper. It's quite a dense one, but it's definitely well worth checking out if you're a student of human evolution, and I'm going to leave it at that. So let me know in the comments below what you thought of it, and until next time, goodbye.